Hey everyone, it's Mr. Loma here. I'm attempting to make some videos for you involving graph analysis. So hopefully this all works out. And let's begin. So first, number one here, we have when is the function above the x-axis? So we're looking right here. I'm going to zoom out a bit so you can see. Okay, and so the first thing you're going to want to do in almost all of these situations is factor to see what you can see. In this case, we're talking about the when is the function above the y-axis. Sorry, about the x-axis. So we're just going to be dealing with y here. So we don't need to do any derivatives with this. It's actually not really a calculus question. So hopefully you're good with your grade 10, 11, and advanced function skills. So step one, we're going to factor. And to do that, the top is a tricky trinomial. So the way I do it, and you can do it whatever way you'd like, but you need two numbers that multiply to negative 72, which is a value times the c value at the end. So 6 times negative 12 is negative 72, and you need two numbers that add up to negative 1, which is the b value in the middle, which is right here, in front of the x. And I know some of you struggle with this. This is why I'm taking a bit of time here. And you need the two numbers that do that, and the two numbers are negative 9 and positive 8. Feel free to write out a list if you'd like, and carry on from there until you find the one that works. So then the way that a lot of teachers do it, some use trial and error, some use inspection. What I'm going to use is called decomposition. I'm actually going to get rid of this for now. So we're going to go minus 9x and plus 8x. So what we did is we broke down the middle term that was negative x into the two pieces here. So negative x became negative 9 plus 8. I hope you agree that that's still the same. And minus 12. And the reason we do that is because we're going to factor this thing in pairs. And one of the reasons I like this method is because you always know whether you did it right. Because when you factor this in pairs, you get 3x times 2x minus 3. And from the second pair, you get 4 times 2x minus 3. And I'm going to put a smile right away because they're both the same. So the two factors are 2x minus 3 and 3x plus 4. Just as a side note, one of the things that I find good about this method is that you end up doing grouping, which is a method you have to know anyways. So there you go. Okay, so we factored the top. Bottom is a cubic. And the first thing you always do is common factor first. And then you get this thing x squared minus 5, which we're going to have to talk about. We could actually factor that if we really wanted to. You could factor it to x minus root 5 and x plus root 5. It's a difference of squares with not a nice perfect square in there. But you could do that if you wanted to. I'm not sure we have to do that. It's up to you guys if you want to do it or not. Okay, so I'm going to switch colors here. So now what we have is y equals 2x minus 3 and 3x plus 4 on the top. And on the bottom, we have the square root of x times x squared minus 5. I'm just going to stick with that one for now. Okay? Keeping in mind that when you have the square root of a number, you have the plus or minus, so there's two answers in there. So what you're going to do next is you're going to find all the regions of the graph that are bad for whatever reason. They have a domain problem, or you're square rooting a negative, or you have a 0 on the bottom, something like that. And so first of all, let's do the easy ones. Find out when this thing is equal to 0. In other words, those are the intercepts. And that is true when the top is 0. So x is 3/2 or negative 4/3. Okay, that's top is 0. Y is undefined. So now we're going to find when the bottom is 0. And we've been using infinite. And I can see that the bottom is going to be 0 when x equals 0 or x equals plus or minus root 5. Now, I made this one a little bit more tricky so that we could see a more difficult one because we don't have to do the derivatives here. So this is the time when we should, give you a little bit of uglier situations. So that's what we've done. Okay, so the problem that gets a little bit funky here is there's a piece of graph that's not very good because we might be square rooting a negative on the bottom. So here's what we're going to do. We're going to make a chart and we're going to put in all the important parts all the important points from up here. And then in a minute, we're going to check to see whether we have any domain issues. And I'm pretty sure we will. So we got root 5, it's the lowest number. And then I believe we have negative 4/3 is the next lowest. And then 0 will be next. And then 3/2 is about 1.1 So that's next. And root 5 is about 2 point something. So it's going to go there. So there's our numbers. You put in zeros wherever the function is 0. That's an intercept. Makes sense. And then you put in an infinity or a u. And some of my work I've been putting in u's. It's up to you what symbol you want to use there. I'm going to put infinity because that's what we've been using this year while I'm making this video. So we'll put infinities in there. And then what we would normally do is we'd start checking intervals in here to see what happens. And in fact, I think I am going to do that because I think you'll discover, if you're careful, everything will make complete sense. So first of all, up here, we're going to try a number that's bigger than root 5. And you can pick any number bigger than root 5, like a million. And if you pick a million, you'll see that this term will be positive. This bracket here will be positive. And underneath the square root, you'll get a positive times a positive, so you get a positive. So everything is positive. So that's good. So that's going to be a plus. Okay? And we're going to do the same thing down at this end. Put in a giant negative. So this will be a giant negative, a giant negative. So two negatives is going to make a positive. And under here, when you put in a giant negative times another giant, we have a positive from here and a negative from there. So when you multiply those, you're going to get a negative under the root. That means this is bad. So there's no graph over there. So this here, over the years, I've called it many different things. Sometimes I just cross it out. Sometimes I'll write domain restriction. Some people just write the word bad. There's no graph there. Okay. So we're gonna chop that piece out. All right. Now let's try another section of the graph here. Let's try a number just a tiny bit bigger than 0. So sometimes you don't have to do all this work. And you're going to see what I mean in a minute where you can save some time. So let's just do this one here. We're putting in a tiny, tiny number like 0.0001. If you put that in here, you're going to get a tiny number minus 3, which is a negative. Here you're going to get a tiny number plus 4, which is a positive. So you've got a negative on the top. And on the bottom, let's see if this can work. If you put in a tiny positive, that's fine. But a tiny number like close to 0 take away 5 is a negative. So we just found another bad section of the graph. So this section here is not doable. This is also a domain restriction. Okay. So unlucky so far. We found 2 bad sections already. So let's see if we can keep going here. Let's put in a tiny number, just a little bit less than 0, and see what happens. So you put in a tiny number less than 0. That one there will be tiny minus 3, which is negative. Tiny plus 4, which is positive. So the top is still negative. On the bottom, if you put a tiny negative in here and a tiny negative in here, so this one's a bit tricky. So this is virtually 0, take away 5, which is a negative, times another negative. So the bottom's actually positive, and you square rooting it. So that's actually okay. So the top was negative, but the bottom was positive. So overall, this thing is a negative, which is okay. Now, I'm glad that happened because now I can show you that I know this one is a positive without doing any work. And here's why I know. The negative 4/3, you may remember this from advanced functions. The negative 4/3 came from this bracket up here, and that bracket has an exponent of 1 on it. I'll even mark it on there for you. And that means it's a pass-through, which means we just zip through negative 4/3 and we switch sign. And it makes sense because that's an intercept. But if you were really paranoid, you could try a number here. So like, for example, I could try negative 2. And if you don't believe me, let's just quickly do it. If you put negative 2 in here, you'll get 2 times negative 2 minus 3. That's a negative. Negative 2 times 3 is negative 6 plus 4 is a negative, so negative, negative. If you put negative 2 in here, that's negative. This will be 4 take away 5, which is negative, so 2 negatives make a positive. So all around you get a positive, which is what we thought. And finally, what's happening under here? Okay, so this one, if you're perceptive, problem here was we had a domain restriction here, so we don't know what happened. Did it switch sign at 3/2 or not? Because we don't know what the sign was here. So I think we're probably better off to try a number like 2 and see what happens. So if we put in 2, you get 2 times 2, which is 4 minus 3, which is a positive. 3 times 2 plus 4, which is positive. 2 here is positive. 2 squared minus 5 is negative. So you have a positive times a negative under the root, which means that we have a negative under the root. That's a problem. That is also a domain restriction. So I'm actually going to cross all of this out as a domain restriction. And hopefully it makes sense to you why that is, because on the bottom where the square root is, anything between 0 and root 5 is going to be a problem. I'm going to go off to the side here for a quick second because some of you are very perceptive and you'll want a faster way to do that. If you think about the graph of, it's actually right here, the graph of the cubic, what does it look like, the piece underneath the root? Well, at negative root 5 it hits, at 0 it hits, and root 5 it hits. And this is a graph that is a regular cubic, so it starts low, ends high. So it's going to go like this, and like this, and like this. So the cubic was negative over here at the left, and I can even highlight it here if it helps. It was negative there, and it was negative between 0 and 5. So I'm pretty sure that's where our problems are going to lie. To the left of root 5, negative root 5, and in between 0 and root 5. And look at what happened. Up here, between 0 and root 5, it's bad. And left of negative root 5, it's bad. So if you're a visual person, which many of you are not, but hopefully you are, drawing this graph can quickly help you. Oh yeah, it's going to be bad there and there because I've got the square root of a negative. So what have we got here? We have done a bit of work. It's asking us, when is it above the axis? So to make our conclusion, you have to always go back and ask what the question was asking you. So it's asking you, when is it above the x-axis? That means y must be greater than 0. Therefore, you're looking for the plus signs in your chart, and the plus signs in your chart are found here and here. And just to be consistent here, I'm going to put an arrow here. Those are the two sections we're looking for. Therefore, we're talking about negative root 5 is less than x is less than negative 4/3, or x is greater than root 5. And those are the two intervals that will satisfy what we need. So that's when the graph is above the x-axis. Okay. I know some of you like the other notation. I'm more than happy to use that as well. X is a member of root 5 to 4/3, not including the endpoints, in union with root 5 all the way up to positive infinity. Obviously can't include infinity. If you prefer that, you can do that. This is what my answer will look like in all my answer keys. It's the notation I use. Anyway, that's it for question number 1, and hopefully that was helpful. Yeah, so I'm just going to zoom out here so that you can see the whole question and pause there. See you in the next video.